Positive attributes of remote sensing. Remotely sensed images provide a number of positive attributes when used as source of spatial data. These positive attributes include large area coverage. Images capture data at a relatively low cost and in a uniform manner. It would take months to collect enough ground survey data to accurately produce a topographic map for 10 square kilometer. Photographs of a region of this size may be collected in a few minutes and the topographic data extracted and interpreted in a few weeks. Extended spectral range. Photos and scanners may detect light from wavelengths outside the range of human eyesight. Some kinds of aerial photographs are sensitive into the infrared region, a portion of the light spectrum that the human eye cannot sense. Geometric accuracy. Remotely sensed data are converted to geometrically accurate spatial data. Aerial photographs are the source of many of our most accurate large area maps. Under most conditions, aerial photographs contain geometric distortion. Permanent record. An image is fixed in time, so the conditions at the time of the photograph may be analyzed many years hence. Comparison of conditions over multiple dates or determination of the conditions at a specific date in the past are often quite valuable, and remotely sensed images are often most accurate source of historical information. Geography has always been important to humans. Stone Age hunters anticipated the location of their quarry. Early explorers lived or died by the knowledge of geography, and current societies live and work based on their understanding of who belongs where. Applied geography in the form of maps and spatial information has served discovery, planning, cooperation and conflict for at least the past 30,000 years, and maps are among the most beautiful documents of our civilization. Spatial information is so important. We have developed tools called remote sensing and aerial photography to help us with our geographic knowledge. A remote sensing and aerial photography help us gather and use spatial data. GIS components are purely technological. They include space age data collectors through remote sensing and aerial photography. Mapping and database creation of most important spatial objects such as rivers and streams may be recorded, and also their size, flow rate, water quality, or the kind of fish found in them. Indeed, these attributes often depend on the spatial arrangement of important features. A remote sensing and aerial photography aid in the analysis and display of these spatial relationships. Remote sensing and aerial photography is a tool for making and using spatial information. Remote sensing and aerial photography and spatial analysis are concerned with the quantitative location of important feature as well as properties and attributes of those features. Objects occupy space. Mount Everest in Asia, Peray in South Dakota, etc. Remote sensing and aerial photography quantify these locations by recording their coordinates, number that describes the position of these features. The GIS may also be used to record the height of Mount Everest, the population of Peray, or the depth of the Titanic, as well as any other defining characteristics of most important spatial features. Remote sensing and aerial photography user decides what features are important and what is important about them. For example, forests are important to many people. They protect our water supplies, yield wood, harbor wildlife, and provide space to recreate. We are concerned about the level of harvest, the adjacent land use, pollution from nearby industries, or when and where forests burn. Informed management of our forests require a minimum knowledge of all these related factors and perhaps above all the spatial arrangement of these factors. Buffer strips near rivers may protect water supplies. Clearing may prevent the spread of fire. And polluters downwind may not harm our forests, while polluters upwind might. Remote sensing and aerial photography aid immensely in the analysis of these spatial relationships and interactions among them. These tools are also useful at displaying spatial data and reporting the results of spatial analysis. In many instances, remote sensing and aerial photography are the only way to solve spatially related problems.